This is a little video mostly for my nephew, but thought other people might find it interesting possibly too. I work for a tech company. I write a bunch of code. I write a lot of it in Python. My nephew is 10, and he's been going through I think he's using the No Starch Press Python for Kids to learn. But anyway, so he sent me some of a little program that he wrote, and it's really cool. It's very straightforward and yeah, pretty cool. So I wanted to take a look at that and then also give some feedback on things that I thought, wow, if I were writing a program like this in my work environment, here are some things I might add to it that I'm not faulting my nephew for not adding them because they would become later on in the learning process. But I just thought it might be cool to show some of the things that might be coming up ahead. So with that said, this is the program. So let's see what it does here. So up here, this is the function declaration. It's going to print a nice little message. It will wait for one line of input from the user, which basically means you type and then hit enter. It'll try to convert that to an integer, and that will be stored in the variable price. If that integer is over 1,000, then it'll print this message. If it's not over 1,000, but it is over 100, then it'll print this message. Otherwise, it'll print this message here. So, and he actually pointed out to me in a follow-up email that, of course, we need import sys up at the top because we're using the sys module, and down at the bottom, of course, we need to actually call the function or nothing happens. So there it is, and we can run Python against that. By the way, I am using Python 2.7, and here's what happens. Prints the message, we feed it some input, and it gives us different output based on what we told it. So perfect, it works exactly as we expected. All right, so the first thought I had was actually just that this here is what we call in the Linux world a captive user interface, and what that means is I run a program, and in the middle of the program doing its thing, it stops and it won't continue until it hears something from me on standard input. So one of the ways this is not awesome is that if let's say I want to run 100 of these, it could be tricky to run a bunch of them in the background. If some of them stop in the middle and want to ask me for something, how do I manage figuring out which one wants me to bring it to the foreground and mess with it? Even if I'm just running one, sometimes I might want to have something start doing a job and then walk away and make coffee or tea, and then I come back and I find out, oh no, it's been, for the last 5 minutes, it's been sitting here waiting for me to give it input. So it's better if we can give it that input ahead of time. Now, a simple way to do this for instance, this is so this is using Bash, the Born Again shell, which is probably the most common shell in Linux environments. I'm actually running this in Cygwin on Windows. But in most modern shells, I can do something like tell it the value, and this would send 500 to standard out. I can use pipe to send the standard out of echo to be the standard in for Toy Talk. So now when Toy Talk goes to read standard input, it's actually going to get what I fed it with echo. So now, bam, it worked. It didn't stop in the middle. So this is one way to manage it. I can even do this in a loop, like for val in 10, 500, 1200, do echo val, pipe to Python, toytalk.py, done. Yeah, so that's pretty cool. We can sort of cycle through testing all the outcomes that way. So we can do that. Another way to manage this is to do it a little more explicitly in the program. So the way I would do that is using one of my favorite Python modules, argparse. And let's see what we want to do here. So actually, in typical, typically in the Linux world, we actually don't want even to print output that is not definitely needed. Some things, like their purpose is to print output. This output about the price is good, but this how much that new toy cost is probably not necessary if we know what we're doing with the program. Let's see here. Let's say parser equals argparse dot argument parser description equals comment on the price of a toy. Parser dot add argument price. We can even do well, let's come back to that. Type equals string, and we're going to say string for now because we'll come back to this later. But sys.student.readline is of course going to read string data from the terminal, and then we're converting it to an integer. There's some other cool stuff we can do, but we'll come back to that. Type equals string, help equals price of item. Args equals parser dot parse args. And let's see. Now instead of price, we're actually going to use args.price. So what this ends up doing, parser has a bunch of cool stuff. When we run parseargs, it's going to evaluate the words that we put on the command line. And in this case, this is a positional argument, which means, well, we'll come back to that, but and we'll say it is required. But it's going to read the first word after the script call. It's going to assign that to price, and then we can read it here. See? So, oh, actually, not quite. Sorry, we still need to do equals int args.price. So I was a little premature here. All right. So now I can do this, and it'll actually say, oh no, we needed, oops, required doesn't matter, so that's fine. Okay, and it'll say, oh no, you needed to give me a price argument. It shows here, see, you're supposed to say price. So I could even run help to see, oh look, it wants price, which is the price of an item. Okay, let's try that then. We'll say 50. Well, this worked out pretty well. So now I don't have to do this echo pipe shenanigans. I can do, where's my for loop? We can just say we can just feed it the value every time. And notice now all the output that we're getting is simply the data. We don't get the question, which is now not really necessary. All right. So let's talk about edge cases. Or bad data. So let's say that I run this and I feed it this argument. So I tell it, well, the price is 100. Well, it didn't like that. Why didn't it like that? Well, because Python doesn't have magic for converting this to an integer, even though a human brain could do it. There's probably some module out there that would do it, but we're not going to worry about that for now. So let's look at what we can do about this. So the problem is happening here when we try to convert this into an integer. One way we can handle this is by using a try loop, or a sorry, not a try loop, but a try block. And we can say accept value error, print bad price input, and yeah, price. So what this does is rather than just printing out all this stuff here, we're just going to print out a nice little message. Now, let's actually, we can say example 10. This will help people understand, okay, that's the format that I'm supposed to write it. And now what we can actually do here is say parser.error. Actually, I think we can do that here. Parser.error. Let's try that. So now we do this. Nope, I lied. That is because I used the wrong thing here. This should say args.price. Okay, that's fine. All right, so now it says, look, you should tell me the price, and 100 was actually a bad input, and you should run -h to see what I actually want. And then they'd run -h and see, oh, look, I should be saying 10, or in this case, 100. Written like this, and now they know what's wrong. Okay. This was actually a nice way to give feedback to the user in a way that looks less scary. In general, it's nice to let the Python error handling is actually pretty good, especially if you expect your script to be run by a technical person. But if this was going to be run by somebody non-technical, we might be able to give them a nicer, more informative message like this. There's another thing I want to point out, which is argparse has this cool thing where we can actually just say argparse dot oh no, what is it? Argparse dot, nope, we don't even need that. We can just say int, type equals int. And now we can say, we really will just use args.price. And let's see here. Of course, oh, right, I took out that line. Haha. Args equals parser dot parse args. We still need that. Okay. The good input should still work, but now let's say we give it bad input. And now it says invalid int value 100. It tells us the -h. So we get sort of the same thing here, but it's all just handled for us because we told the parser that what we wanted was an integer, and it does all this magic for us, which is pretty cool. Anyway, there's another error case that I wanted to talk about. 100 works. What if I say -100? Uh-oh. This is weird. So one thing that we should think about when we're programming, and this is what we would call writing code defensively, is we should probably check for all the boundaries. In this case, it doesn't make sense to have a negative value, so we should probably have something like elif args.price is less than or equal to 0, print negative values not allowed. And actually, here we might want to do a parser.error as well, because here we actually it is an error. It's not an acceptable output. And I'll show you one of the ways that could matter. So actually, if we so this error message actually came on a channel called stderr, standard error, whereas the nice messages come on a channel called standard out, and you can see the difference here, 2 and 1. So in a normal in a standard POSIX terminal, there are 3 built-in channels, I/O channels, 0, 1, and 2. 0 is standard input, which we already were reading from. So that's your input there. 1 is standard output, and this is to be used for normal output. This is informational data. This is like what the program is supposed to say. And 2 is used for error output. It's called standard error, and it's used for printing error messages. Something bad happened. So it's if we use parser.error, it's going to just respect that automatically. There are ways to even print. There's an argument you can pass it to have it print to stderr if you wanted. Although raising exceptions, using parser.error, just we get that it's respecting that for free. So anyway, yeah, so we covered the idea of captive user interfaces and how to get around them, either by using pipes to pass data to standard input, or by just using command line arguments, which is a really nice way to go. We talked about handling just garbage values that can't parse, and we also talked about handling values that might actually be valid but out of bounds for what we want to consider. So anyway, here's what I ended up with at the end here. We import argparse and sys. We build a parser, has a nice description. We tell it to expect you to tell it a price. We crunch the data there. We check if it's over 1,000. We check if it's over 100. We check if it's under 0 and print an error if so. Oh, one thing we might just change here is to it might be better, yeah, fail fast. If we have a bad value, we might as well just catch that earlier rather than later. And then, yeah, so lastly, if it's over 0 but under 100, then we're going to print I can afford that. So there you have it. That's the final version that I came up with. I don't think that any of this is necessarily all capitals the right way. Just some things I've learned, and probably some things that I would, if a coworker sent me this code for review, these are things that I might ask to be added before we started actually using it. So there you go, and have fun coding.